Q3734-2. An uncommanded, rapid yaw towards the advancing blade which does not subside of its own accord is known as A. A loss of tail rotor effectiveness. B. Vortex ring state. C. Main rotor disc interference. The correct answer is A. An uncommanded, rapid yaw towards the advancing blade that does not subside of its own accord is known as a loss of tail rotor effectiveness. This phenomenon can occur at high angles of attack and low airspeeds, particularly in certain flight conditions such as high-density altitudes or high gross weights. It can result in a sudden and uncontrollable yawing motion of the helicopter, which can be hazardous and may lead to loss of control if not addressed appropriately. 3734-3. What flight activity or condition would lend itself to a higher risk for loss of tail rotor effectiveness, LTE? A. While on short approach to landing at a heliport. B. During departure from a heliport in a no-wind condition. C. In a low and slow situation over a remote area. The correct answer is C. A low and slow situation over a remote area would lend itself to a higher risk for loss of tail rotor effectiveness, LTE. LTE is a phenomenon that can occur during certain flight conditions, particularly at high angles of attack and low airspeeds. In a low and slow situation, such as hover or low-speed flight, the helicopter is more susceptible to LTE because the airflow over the tail rotor may be disrupted, resulting in a loss of tail rotor effectiveness and an uncommanded yaw. This risk is further amplified in remote areas where there may be limited options for immediate recovery or landing. 3738. If anti-torque failure occurred during the landing touchdown, what could be done to help straighten out a left yaw prior to touchdown? A. A flare to zero airspeed and a vertical descent to touchdown should be made. B. Apply available throttle to help swing the nose to the right just prior to touchdown. C. A normal running landing should be made. The correct answer is B. If anti-torque failure occurred during the landing touchdown and there is a left yaw, the pilot can help straighten out the yaw by applying available throttle to help swing the nose to the right just prior to touchdown. This action can help align the helicopter with the intended landing direction and mitigate the effects of the yaw caused by the anti-torque failure. It is important to apply the throttle smoothly and judiciously to avoid any abrupt changes in yaw or other control inputs. 3739. Which flight technique is recommended for use during hot weather? A. Use minimum allowable RPM and maximum allowable manifold pressure during all phases of flight. B. During hovering flight, maintain minimum engine RPM during left pedal turns and maximum engine RPM during right pedal turns. C. During takeoff, accelerate slowly into forward flight. The correct answer is C. During hot weather, it is recommended to use the flight technique of accelerating slowly into forward flight during takeoff. Hot weather conditions can adversely affect helicopter performance, including reduced engine power and decreased rotor efficiency. By accelerating slowly into forward flight, the pilot allows the helicopter to build up forward airspeed gradually, which can help maintain proper rotor RPM, improve rotor efficiency, and enhance overall aircraft performance in hot weather conditions. 3740. Under what condition should a helicopter pilot consider using a running takeoff? A. When gross weight or density altitude prevents a sustained hover at normal hovering altitude. B. When a normal climb speed is assured between 10 and 20 feet. C. When the additional airspeed can be quickly converted to altitude. The correct answer is A. A running takeoff should be considered when the gross weight or density altitude prevents a sustained hover at the normal hovering altitude. In situations where the helicopter is heavily loaded or operating at high-density altitudes, it may be difficult to achieve a sustained hover due to reduced lift capability. In such cases, a running takeoff can be performed, allowing the helicopter to accelerate and convert the additional airspeed into altitude more efficiently.